Hi, welcome to video tutorial on vDAG, which is building scalable and distributed AI workflows with the AIOS V1 blocks concept. So first of all, I'll be using Jupyter Notebook for the entire demo, and this code will be hosted in the GitHub, so you can use it and experiment it. So to give an introduction, what is vDAG? So in the modern AI system, to build a powerful application, you can have a single powerful model. This is one way. Other ways are maybe you can have multiple smaller models which they can execute their own smaller portion of the big job. So that is one other way we can get a bigger AI. So this is where the vDAG, which is known as virtual directed acyclic graphs concepts come in, and it's a game-changing abstraction for designing a distributed AI workflows. vDAG represents basically a virtual workflow composed of interconnected AI blocks. Each block serves a specific AI computational function, and these blocks are created and deployed by individual developer with the help of our AIOS instance SDK. So this is must needed for the blocks so that blocks can communicate to the AIOS backend, and the scaling also can be done for the individual blocks on demand. And what makes the vDAGs powerful is that they allow you to build an end-to-end application using the distributed blocks. Not just you don't have to have all the blocks in the same node. It can be distributed across the cluster or in the same cluster, and orchestrating them across the graph structure can span within or same across the cluster. So this is the general introduction to the vDAG. So before getting into vDAG, so we need to understand what is block. So in AIOS V1, block is a core serving component of AIOS V1 ecosystem. So it represents a self-contained unit which is responsible for, let's say, doing an instantiating or serving an AI model. Or it could not just a model, it could be in general purpose computation, or it could be general purpose code. And it can scale based on the load. So you can write policies for scaling or load balancing. All those policies you can write for individual blocks, and it is being managed dynamically across a distributed cluster environment. So these are the responsibilities of a block, and blocks can be deployed by any user in the cluster where they have access to. And once they deployed, these blocks can be a part of a bigger vDAGs. It can be or it can be run as a separate ad hoc inference endpoint as well. So both are possible. Block can be part of a vDAG, or they can stay alone and they can give an inference, ad hoc inferences. What is vDAG? So vDAG is basically a virtual, it's a virtually directed acyclic graph where workflow composed of, it is nothing but a workflow composed of blocks, where each node in the graph is a block. Even it's not just about block, it can be an separate smaller sub vDAG itself. That's also possible. So it defines how data flows through sequence of operations such as pre-processing, model inferencing, post-processing. Multiple such blocks can be available, and it can be executed across a network of the blocks basically. So the keyword here, virtual, refers, it is not like hardwired. So blocks are running in the AIOS ecosystem. You are just connecting them as a graph, and there is no hardwire. So you can anytime you can remove those vDAGs, till the blocks will exist. So the blocks refers here existing block deployed in a cluster. So think of a vDAG as a blueprint or a routing plan. So it is not nothing more than that. So you can think of a blueprint or a routing plan. And basically this plan will tell you how a particular task should be processed by different blocks across the network. So the key features of a vDAG, it's a modular composition. Each node in the block that can be reused in multiple workflows, or it can be used standalone. Nested graphs is possible. A smaller subgraph can be created as a part of a bigger graph. Cross cluster execution. So nodes can reside on the same machine, same different machine of the same cluster or different cluster. So all those combinations are possible. Assignment policies. So you don't have to hardwire any blocks. If you have in the cluster there are so many blocks, you don't know which block to choose. You can write certain policies, like say I want best accuracy, I want best accuracy for this job, I want best accuracy for, I want a speeder execution. So such kind of policies you can write. So execution, the policy writing is not part of this video or tutorial. It will be available in certain other videos. And custom behavior, let's say each node, like which is nothing but a block right now. So each blocks will have can have its own pre-processing and post-processing policies. So this pre-processing policy will execute before the core functionality of the block, and post-processing policies will execute post the core functionality. So this will help in the transforming maybe the input, or maybe transforming the output, validation of input or output. Those all are possible with the help of pre-processing and post-processing policies in a vDAG. So flexible patterns, like you have fan in, fan out logics are supported here, where a single block can get an input from a multiple block, which is like a mux kind of operation, and demux is possible. So where a single block will output into a multiple different sub blocks. So the mux and demux operations are possible in the vDAG flow. A single consumer can be there, ensembles, branching, all those patterns are possible in the vDAG construction. So vDAG's end-to-end workflow. So right now we will register a vDAG. So this vDAG will have multiple nodes in it, and each node will represent a single block. Maybe it's with its pre-processing and post-processing units. And then once a vDAG is registered, you need to create something known as a controller, a vDAG controller we call it as, that manages a whole lot of things. Maybe it could be channeling the inference request, it could be a routing, it could be health monitoring, certain policy executions. All those things will be taken care by this controller. And how to do the health monitoring or policy execution will be explained in the next video. Submitting a real inference request using multimodal inputs. So right now in this workflow we'll show multimodal inputs, and then clean up the controller after use. So if vDAG controller is of no use, we can clean it up. So this is the workflow for this particular demo. So registering the vDAG. Right now I have 3 blocks with me, which is already deployed in the AIOS system. How to deploy a blocks I will not explain here in this video. So there are separate videos for this. So I have a Gemma 3 27B block, and I have a Llama 4 Scout 17B block, and I have a Magistral block. So in each of the blocks are given a task, or given a system message to do something. So let's say this Gemma block, it's a multimodal model, so it can take images and text. So we are asking it, by giving an input image, we are trying to ask and extract semantic scene information from it. So like what all objects are available, what's all environment is going on, any interactions are going on, such kind of informations we are trying to extract from this particular model. And then we have a Llama 4 Scout. It will be like an understands the previous output sent by the previous block, and it will try to understand what all different combinations of the events are possible. Is there a theft going on, a fight going on, snatching going on, accident is going on, with the information provided by the previous block. So once it provides all the details, it's like a kind of doing a police work. And once it is done, the last block, it does basically a call to alert whether to escalate this or not. So it can be alert or notifications, and also along with that, to make it a little bit more complicated, so we have added some extra things to this post-processing. What we have done is we have asked the Magistral small model to create the codes that is needed to deploy a job in our AIOS v1 ecosystem, so which I will be explaining later. So here user input will come to a vDAG controller. vDAG controller routes the input that it receives to the first block in the vDAG, which is a Gemma 3, a node in the vDAG, the Gemma 3 block. And Gemma 3 block, once it gives the output, it directly goes to the Llama 4 Scout model, and then from the Llama 4 Scout, it will go to the Magistral block. And the Magistral block, it says whether to alert or not, and then it generates certain codes, and those codes are given to the post-processing logic, which will be executing along with the Magistral block. So that post-processing logic basically passes the output of Magistral block, and then it deploys those codes generated by the Magistral block into the function space of AIOS v1. And in this function space, we are deploying a job, which is a fire and die kind of a job we'll deploy. What it does is, this job basically pushes something to an third-party endpoint. So right now I have a third-party dummy endpoint which just receives the input only, it is not doing anything else. So that fire and die kind of a job will be deployed, and then the post-processing will return back the controller to vDAG controller, and then it will come back to the user as a response. So here, if you want to know more about functions, right, so you can click the link here. So we are running the policies as a function. There are different kinds of policies, which I'll not explain in this video. So you can see type 1, type 2, type 3, type 4. Right now we'll be executing type 3 policy, which is policies deployed as a job on a remote cluster, which is a stateless policies. I don't require a state here because it is a fire and die job. So it is a stateless policy only I'm going to deploy right now. And to know more about vDAG and spec specification related, right, so you can go to this particular link to understand how the vDAG specifications are created, what all fields are available. To know more about that, you can read it here. So here's a Python script I have next stage, so which will register the vDAG JSON. And when we register a vDAG JSON, it requires certain fields like what is the vDAG name, and what is vDAG versions, release tags. All those things are required here. Right now I have given LLM analyzer August 16 as a name of it, and 006 as a dummy version, and a stable release tag. So when vDAG is registered, basically you will get a name of the vDAG like this. So vDAG name will be there, and vDAG colon separation, there will be a vDAG version, and then vDAG release tag. So this will be the whole URI of the registered vDAG. So let me go ahead and create the register this vDAG. So here is the API create vDAG. So to this endpoint, I have to submit a big payload. So that payload I'll explain here. So right now the payload has a details like vDAG name and vDAG version, some discovery tags, you can give certain tags to it, and then nodes. So it's a list of nodes here. So right now, as I mentioned, we have 3 nodes here in this vDAG. The first node which is there as a gemma. Right now I'm not creating a graph, it is just the available nodes only. It is just a list of nodes. So I have a gamma block. So right now I'm giving a node label to it. Node label could be any random strings of your choice. So right now I'm giving the same name as a block ID, and this node label will be utilized throughout this JSON file or a payload. So I have given a node label, a dummy name, node type, which is a kind of a block, not a policy or anything. So, and manual block ID, I am directly right now assigning to a already available block for the purpose of demo. So this block already exists. As I told, I will not explain how to create these blocks because it is out of scope of this video. So block is already created. I'm using that block. I'm directly manually assigning it, and this is the node label. This is the first node in my vDAG. So second node is a Llama 4 Scout model. Again, I have given the same name as a block ID, and this is the block ID, Llama 4 Scout as a block ID. And third node is a magistral block. So I have given the node label same as a block ID. So you can give any node label to it. And one important thing is there is a post processing rule. So right now I am creating a post processing, I'm adding a post processing role which I have already registered. So to know how to register, this is not the right video. How to register, you need to check separately. So you need to have a prerequisites of how to deploy a blocks in AIOS cluster is required, and you need to know knowledge about how to register the policies also required. So you have to watch those videos to understand registration of a policy, and creating the blocks in AIOS is required before this video. So there is a post processing policy that I am attaching to this particular magistral block. And once all the nodes are defined, and then comes is the graph definition. So graph will have input, output, and a connection. In the input section, since my gemma 3 is the first block, I have mentioned as a gemma 3 block, and output block, the last block, is a magistral block, and in between connections I am giving it here. So this is one connection, and this is one connection where second model takes the input from the first model, and the third model takes the input from the second model. So this is the entire payload of a vDAG. So it can have many more fields. I have not put all the empty fields, so just to keep the the demo simple. And so right now I can run this block. So once I run this block, vDAG will be registered in a AIOS space. Let me run it. I got a response saying that it is successful, and to check whether the registered content of a vDAG, so you can use this particular API vDAG analyzer. You have to give all the complete URI of the vDAG. So let me run this script. So now it is giving all the details related to the registered vDAG. So all the blocks, all those informations are present here. I'll not go in detail for related to this information. And then once a vDAG is registered, you need to deploy a controller, vDAG controller. vDAG controller basically gives you a runtime engine for the vDAG. So vDAG, when it is registered, it doesn't have any runtime engine. Right now, once we create a controller, we will get a runtime engine. So right now, the runtime engine vDAG controller does basically task routing between the blocks, health checking and quota monitoring. So this, I have separate video for it. And then quality management, you can check whether the output has come from the blocks are proper or not, whether you can do it manually, or maybe you can send it to some place where automation can be done. So such kind of things can be achieved in this policies of the vDAG controller. So for creating the vDAG controller, certain things are required. So you have to give one controller ID, name, string. So right now I'm giving AUG6 controller, and you require the vDAG you have already created. So vDAG we have already registered, and that URL is LLM analyzer 6, AUG6 and 006 table. So that vDAG URI you need to provide. And a policy execution mode. What that means is, for a last block, right, we have registered on policy post processor for job caller. That is a policy name, and we want this policy to be executed locally within the last block. So I don't want that policy to be executed somewhere else. Let it execute locally within the block. So you can create a multiple replicas of the controller. Let's say you have so much of inputs coming in, and single controller is not enough to handle the load. So you can always create replicas of it to control the number of inputs you are receiving. So let me run execute this right now. Yes, the controller also has been created successfully. And let me check what all are the whether the controller has created successfully or not properly. To get the more details about the vDAG controller, I am executing a vDAG controllers by vDAG URI. You can give the vDAG URI, complete vDAG URI, and it is returning certain results to you. Or on one other ways, you can ask for the controller directly. You can give a controller also and get the details, same details. You'll get the same details as the above. So basically, in this response, whatever you got, so certain things are very important for us. So here you will get to know which cluster ID it is executing in, and certain configurations, policy, public URL of the whole controller is available here, and what is a vDAG controller ID, what is a vDAG URI, all those details are present here. What is important here is these two, API URL and RPC URL. So every vDAG controller exposes a REST API and gRPC API endpoints. So you can use REST for REST APIs. Let's say submitting an inference request you want to do, you can use either REST or a gRPC. Whereas if you want to do some management actions, like management in the sense, let's say for this vDAG controller you have created, you want to control the quota for certain session IDs. So let's say a session ID with my username is having only, let's say session ID can be a username or any sort. So let's say session ID has a quota of 10, only 10 requests you can do. So by paying more, if they want more, they want to increase the quota. So basically you need to let controller know. So for that, you can use the management commands. So not just that, you can use it for a health checker, you can do for management command for a quality checker, quota checker. So all this you can use it, and you need to use the REST API only, not a gRPC. So here config API URL is for a REST API, and RPC URL is for gRPC request. So let us run an inference on the vDAG. So right now vDAG is registered, a vDAG controller is created, and I want to run an inference now with the help of vDAG controller. So what all things are required? Input, the session ID is needed, a sequence number is required, and data mode, basically a chat interface is required, and the input, the actual payload. So what happens? The request is received by the controller, and it routes the input to the first block, which is a vision analysis. It takes the image as well as the text that we have shared, and it analyzes something, and then it passes on its output to the second model for event detection. And once event is detected, for decision taking or alert triggering and registering the function as a job, so it will go to the last block. So I have a bash script here. So when I execute this bash script, it might take some time because the data has to channel through all the individual blocks, and all the individual block has to process it, and then at the end output has to come. So it will take some time. So right now, as you can see, I have given a session ID. So this is the same endpoint. So I need to replace the endpoint that I got here, which is API URL. Since I'm doing a curl request, which is a REST API, so I'm using this particular endpoint, and I'll replace it here. So now we can do an inference request. So never ever forget to replace this URL because it is specific to this particular vDAG controller, and I'm giving certain mode and generation parameters for the LLM. And in the message, I have a separate structure for it, so where I'm passing a text as well as a image. So let me just copy paste this image, the content of the image. So before that, let me run this, as it will take some time. I will not be able to show you any intermediate responses from the LLM right now. I have a separate demo for it. So let me just run this. So it will take time. So meanwhile I'll show you the image. So here the image looks like it's not that great quality. So there are 3 sequences. So some blue shirt guy is going and getting something from the woman, and she falls. The image is not that clear to me, and also LLM also will states that the image is not clear. So let us see how the LLM takes. So this when I show you Streamlit app demo of this REST API, you will understand who is causing delay here, because there are 3 blocks. There are the last block, which has to generate a lot of codes to deploy it in AI Voice Wave, and that's why the delay is. Yes, the final response has come now, and it is from the last block only. It doesn't have an intermediary blocks result. I'll not be able to show in this request, curl request demo. So it has analyzed something. We'll again see it in the later section. Right now, this is the REST call. So you can do similar to the gRPC call, which I'll not be doing it. I'll give it to the user, so you can try executing it if needed. So you just have to replace certain things here. The URL, you need to replace it from the above that you received, right? gRPC RPC URL, that you need to replace it, and you need to run it. So that will also take some time, so I'll not go to that. And cleanup we'll see later. Let's see an live demo with the Streamlit dashboard. So the Streamlit code is provided in the repository. The Streamlit codes are available here. So you just have to install Streamlit, and you have to run this app. So I have already I'll just run it in my terminal. Yeah, a Streamlit interface has opened, and it is mainly for a LLM connection. So before that, you need to take care of a few things in this file. So you need to provide your vDAG URI, what vDAG URI you have created, right? So that you need to supply here, and also the controller name. So right now, whatever the controller name and vDAG URI I have created, it is available here, and I am creating some session ID, a different session ID, and once that is run, it will display you the certain details about the vDAG by querying the vDAG API. So user input, first block, second block, third block, last block is magistral small block, and it displays certain other informations. Right now these blocks are ready. I can give any input. So here I will attach the URL directly, because I have the URL. This URL is nothing but the same image URL, and I have to give some message to it. So that message I'll try to copy it from the demo example. Analyze the following image and generate your objective scene report. So right now my code will try to get the WebSocket of all the blocks because it knows the block has a WebSocket connections available. With that, it will try to by connecting to the each and every WebSocket, it will try to get the streaming tokens. So it is displaying the tokens one by one. Yeah, so this is the last part. The magistral block is doing some activity. So first let us see what it and individual blocks are doing. So key elements and observations. So people, there are certain people here. Several people are present. A man in dark blue t-shirt is prominently featured and appears to be involved in the situation. There's another individual in a green and red outfit, and the person on a scooter, another person is lying on the ground. So we have given instructions to extract all the entities available in the image or scene. So about vehicles, there is auto rickshaw, tuk-tuk is visible, cars in the background. Action sequence of images suggest possible physical altercation. The man in blue appears to be interacting with the person. So environment, it's a paved street in a urban suburban area. It's a wet pavement because of rainfall. It's saying because of the quality of the image, it has predicted certain things. And then analyzer. So basically reasons out the previous output will be given to the llama scout, and it is trying to analyze this. So it is giving certain confidence of its own. And what are the reasonings? Visual cue sequence of images suggests possible physical altercation between the man and the dark blue shirt, the person on the scooter, and interaction between the two individuals. The final frame showing person lying on the ground supports this conclusion. So contextual clues, wet pavement, urban setting suggests that incident may occur recently in a public place. Limitations, image quality and static representation of dynamic event limits the accuracy of the analysis. So potential, it might be saying like there can be a potential assault, or there could have been an accident, involvement of other individuals, because it looks like the presence of other individual, including person in the green. Red output, the auto rickshaw driver may indicate that incident was witnessed or potentially involved multiple parties. So it is giving some more information related to the report analysis. And then comes the last event analysis. So it is finally classifying it as an alertable, and when it is alertable, we are giving some asking it for a summary. And then the later section is about the code generation. Now the processing is over. Let me go to each and so I have explained the summary. And now file generation. So the second part is about the file generations needed for AIOS v1's function deployment. So it is generating one Python file which is having same structure as our AIOS policies. So basically it is doing one request.post to one URL and the payload. So payload structure is here, and this is a very simple function. Basically we are trying to push something to a third-party endpoint, and all the URLs here, right, the destination URL, I'll be replacing it with a placeholder. So now you have a code to be executed in the function space, and you require a registration as well. You cannot simply run a function like that. You cannot simply run a policy like that. You require a registration of it. So for registration, you require a registration JSON, and we have given a structure of our registration JSON to the magistral model, and it is generating a registration file here. So once registration file, in the registration file, you will see a lot of placeholders that will be replacing by in the post processing policy. We have replaced all these placeholders with the proper IPs and ports, and a registration file is available. Now there is a pusher.sh. What its responsibility is, whatever the code it has generated here, it has to zip it, archive it, and then push it to a certain endpoint where it is supposed to be available. So there is an endpoint here, which is basically it is storing all the policies zip files in this endpoint. So this bash script will be responsible for pushing the zipped file of the code, and there is a bash script to the registration. So it has a registration file being generated, and it has to register it. So it will take that registered file and the registration.json, and it will do the registration to the endpoint provided here. And there is a bash deployment. So basically once function has been registered and it has been registered, it needs to be deployed. So for that deployment, it has created one more deployment.sh file. What it does is there is already an executor created. So what is executor, I'll not explain here in this video. There is a separate video for it. So to the executor, I am going to give a job, and that job has this particular URI, and this URI has a registry. What is this URI? Which is nothing but basically coming from the registration only. So registration JSON, and it understands when the job is about to run, right? So this URI is nothing but this particular, it will understand the content of this registration file. In the registration file, we have given all the details, like where the zip file is. All those details are available in this registration file. So once the job is deployed, it will try to understand what is this. From the AIOS v1, it will pull the zip files and it will execute. There is a dummy message here, it will be replaced later on. So this is the deployment job script. So right now, since this all will get executed, I mean though this is the output of the LLM, this LLM output will go to the post-processing code, and the post-processing code will be executed as a part of the block only. So after the block's execution, post-processing block will execute, and what post-processing block will do is this will pass this particular result. It will do a regex operation to get all the individual sh files, and it will execute one by one. Let's say it will it zips the file, then it pushes the file to a endpoint, then it registers the JSON file, then it deploys the job, and then gives the control back to the vDAG controller. And once the job is deployed, as we told, it's a fire and die. So job will run and die, and the job's responsibility is to put something into the third party endpoint. Now I have created a dummy endpoint which just receives the data and displays the content. So here it is. So it has pushed something, some message content, a critical event involving physical. So basically we can send this to a dashboard or anything from the basically it's in third party endpoint. That's it. So this is the whole demo we wanted to show. So here just to summarize vDAG, we explained like what is vDAG, what is blocks, what all blocks capabilities, what all vDAG's capabilities, and we registered a vDAG, then we deployed a vDAG controller, and post vDAG controller deployment we used a REST API to do inference. We can use a gRPC endpoint also, and then we did a demo with a Streamlit app where we showcased individual blocks, streaming results of individual blocks with the help of WebSocket, and you can it's in multimodal vDAG. So first block takes the input image and the text, and the rest all takes only the text. So basically whole vDAG can be broken down into a smaller individual blocks to do a bigger job. So that's the purpose of this demo. So thanks for watching.